Good day, sir. Good day, classmates. Good day to the viewers. So, for today, we'll be proceeding to the part 2 of our video discussion, which now talks about the differential equation. So, but for now, we will just focusing on the first order differential equations, which involves the first derivative of function and describe how function changes at a certain rate. So, these are used in various fields to model situations like population growth, fluid flow, or electrical circuits in different fields. No? And now, let us try to have an example. So, let us try to look at this. Now, we will have 2x plus y multiplied to the cosine of xy with respect to x plus x multiplied to the cosine of xy with respect to y. So, for this one, we're going to apply the exact equation. So we were going to let m be equal to 2x plus y cosine of xy. No? So we will take the partial derivative of m. So for this one, we were going to apply the product rule. So the cosine of x and y, the prime multiplied to y plus y prime multiplied to cosine of xy. So the derivative of the cosine of xy is negative sine of xy multiplied to x and multiplied to y plus the derivative of y, which is 1, multiplied to the cosine of x. And next thing we do is simplify. Now, what we have is the negative of xy multiplied to sine of xy plus cosine of xy. So, the cosine of xy minus the x times y times the sine of xy. Now, next is we're going to let n be equal to x cosine of xy. So, for this one, we're gonna apply again the product rule to get the partial derivative of n. So, with respect to x. So, what we have right now is x prime multiplied to cosine of xy plus the cosine of xy multiplied prime multiplied to x. So, what we have is the cosine of xy minus xy times sine xy. So, they're both the same. The next thing we do is that our partial derivative of x equals to x multiplied to the cosine of xy. And we were going to apply the integral to the partial derivative and also to the function of x cosine of xy. So, the integral of partial derivative of f is f of x, which is equal to x multiplied to the integral of cosine of xy with respect to y. So, for this integral, we will gonna apply just the u substitution, which we're going to let the u be equal to xy. Now, so take the derivative of u, we will have the x dy, which equals to dy du over dx. Now, the next thing we do is that f of x equals x multiplied to the integral of our cosine of u du over x. So, x over x equals to 1. Now, so what we have right now is that f of x equal to the cosine of u du. And now, the f of x now is sine u, since the integral of the cosine of u is sine u. Now, what we have right now is f of x equals to sine of xy plus t of y. And now, the f prime of x equals to the sine of xy prime plus t prime of y. And now, the f prime of x is equal to 2x plus y multiplied to the cosine of xy equals to the sine of xy prime plus t prime of y. And now we will take the derivative of our sine xy, which is y cosine of xy. So what we have right now is 2x plus y multiplied to the cosine of xy equals to y multiplied to the cosine of xy plus t prime of y. Since y cosine of xy equals to y cosine of xy, we can treat this, we just can cancel them out, no? So what we left here is 2x equals to t prime of y. So to get the t of y, we will gonna apply the integral on both sides. So the integral of the t prime of y equals to ty. And now we will try to solve the integral for 2x with respect to x. So what we have right now is the t of y equals to 2x squared halves. No? So we can just simplify this expression and turn into x squared. Now what we have right now is that f of x equals to sine of x plus x squared. So that is the final answer. And now let us have a new example. Now which is the quantity of y minus x plus x y multiplied to the cotangent of x with respect to x plus x with respect to y equals to 0. So for this one, we're going to apply the first order linear ordinary, which we have to multiply both sides by 1 over x dx. So what we have right now is that x over y plus y cotangent of x with respect to x plus dy over dx equals to 1. So for this one, we need to factor out y. Now, so what we have is dy over dx plus y multiplied to the quantity of 1 over x plus cotangent of x equals to 1. And now, we will gonna let v be equal to e raised to the power of the integral of 1 over x plus cotangent of x dx. So, the integral of 1 over x is ln of x, and the integral of the cotangent of x is ln of sine x. And now, what we have right now is v equals to e raised to the power of ln x plus ln of sine x. So we will gonna apply the law of logarithmic, which we will have now that v equals to e raised to the power of ln of x multiplied to sine of x. Now, what we have is that v equals to x of sine x. Next thing we do is that we have to multiply the x sine x to both sides. So what we have right now is x of sine x multiplied to quantity of dy over dx plus y over x plus y multiplied to the cotangent of x equals to 1, which should be multiplied also to x of sine x. Right here. So what we have right now is x of sine x multiplied to dy over dx plus y x sine of x all over x plus y times x times sine of x times cotangent of x equals to x sine of x. What we have right now is to simplify. By simplifying the terms, we will have now the x of multiplied to sine x dy over dx plus y multiplied to sine of x plus x multiplied to y multiplied to sine of x multiplied to cotangent of x equals to x multiplied to sine of x. So for this one, we will have the sine of x multiplied to y prime equals to x sine x. So for this one, no, we will apply the integral. So the integral of x of sine x dx. So for this one, no, we will have to use the integration by parts. So to solve this integral of x of sine x dx, we will going to let u be equal to x, the derivative of u, which is equal to dx, and our dv be equal to sine of x dx. And to get the v, we apply the integration. What we have right now is the v equals to negative cosine of x. So substitute them. What we have right now is x y sine x, sine of x, equals to x multiplied to the cosine of x minus the integral of the negative cosine of x plus dx. As you can see here, we can simplify the negative multiplied to negative be equal to positive, and negative multiplied to positive be equal to negative. So what we have right now is that y multiplied to x sine of x equals to negative x rather multiplied to the cosine of x plus the integral of our cosine of x dx. So for the cosine of x dx, the integral of it is negative sine. So what we have right now is that xy multiplied to sine of x equals to negative cosine of x minus sine of x plus the constant. Now, so to simplify this expression, all we have right now is divide both sides by x. X multiplied to sine x. What we have right now is x negative x cosine of x all over the x sine x minus the sine of x all over the x sine of x plus the constant all over x sine of x. So what we have right now as y now is that cosine of x over sine of x minus 1 over x plus the constant all over the x of sine x. Next is this. For the item 10h, we will have the y prime equals to x minus 2y times the cotangent of 2x. So for this one, we also have to apply the first order linear ordinary. No? So what we have is that y prime plus x minus 2y multiplied to the cotangent of 2x. So what we have next is that y prime plus 2y multiplied to the cotangent of 2x equals to x. So what we have here is that we can now let the v be equal to e raised to the power of the integral of 2 cotangent of 2x with respect to x. So for this one, to the integration, we were gonna apply the u substitution. So we're gonna let u be equal to 2x and the du be now is that 2 dx and the d over 2 is equals to dx. So we can now substitute. Now so what we have is that b equals to the e raised to the power of the integral of 2 multiplied to the cotangent of u multiplied to the du over 2. So 2 over 2 equals to 1. No? So what we have next is that b equals to e raised to the power of the integral of the cotangent of u with respect to u. So the integral of cotangent of u is ln sine. No? So what we have is that v equals to e raised to the power of ln of sine u. So what we have as, and since we let earlier 2x, the next thing we do is to substitute back what we let earlier, which is u equals to 2x. Now we have that v equals to ln times ln of sine x of 2x. So what we have for v is sine 2x. The next thing we do is to multiply both sides by sine of 2x. So sine of 2x multiplied to y prime plus 2 y cotangent of 2x equals to x multiplied also again to sine of 2x. The next thing we have right now is sine of 2x multiplied to y prime plus 2y multiplied to sine of 2x times the cotangent of 2x equals to x sine 2x. So the partial derivative of x be equal to x sine 2x. So to get the f of x, we apply the integration for both sides. So y of f of x equals to the integral of x sine 2x. So for this one, we will just gonna apply the integration by parts. So we have to let u be equal to x, then the derivative of u equal to dx, and for our dv, we're gonna have the sine of 2x. So the integral, to get the v, we have to apply the integral. Now, so what we have for v is negative 1/2 cosine of 2x. So next is that our y of f multiplied f of x equals to x multiply to negative 1/2 times cosine of 2x minus the integral of the quantity of the negative 1/2 cosine of 2x with respect to x. Now, to simplify each expression, since the integral of the negative 1/2 multiplied to the cosine of 2x with respect to x is positive 1/4 sine of 2x. So what we have written is y f of x equals to negative 1/2 x cosine of 2x plus 1/4 sine of 2x plus the constant. So our f of x here is that y equals y multiplied to x sine of 2x prime equals to negative 1/2 x multiplied to the cosine of 2x plus 1/4 sine of 2x plus the constant. So what we have right now is that y equals to sine 2x equals to negative 1/2 multiplied to x multiplied to the cosine of 2x plus 1/4 multiplied to the sine of 2x plus the constant. So we divide both sides by sine of 2x. The next thing we have right now is y equals to negative x multiplied to cosine of 2x all over 2 times cosine of 2x plus 1/4 plus the constant all over the sine 2x. So that is the answer. So I hope you learned something. Thank you and God bless you all.